Single replacement reactions. In a single replacement reaction, one element substitutes for another in a compound. So we went from A plus BC, we're going to have the A replacing the B, and that leaves the B out here. The reaction proceeds when an elemental anion is more chemically active than the compound's anion. Remember, anions are negatively charged, or when an elemental cation, positively charged, is more chemically active than the compound's cation. The two competing elements in this case are A and B. The element C is called a spectator ion since it is not part of the competition. It is in the compound regardless of the outcome. It's either BC or AC. If A is a cation, it competes to displace the cation in BC. If A is an anion, it competes to displace the anion in BC. Typically, a metal ion competes to displace a metal ion in the compound, or a halogen ion competes to displace a halogen ion in the compound. You are not expected to memorize the chemical activity of elements. You will be provided that information, or more commonly, be expected to infer it from a provided reaction. These reactions can only proceed in one direction, since once the more chemically active element is in the compound, it won't be displaced by the element it displaced. This is unlike the composition and decomposition reactions, which are mirror images of each other. In the first reaction, we see that the zinc is more chemically active than hydrogen, so it displaces it. In the second reaction, we see that chlorine is more chemically active than iodine, so iodine is displaced. These reactions do not proceed. Why do you think that is true? Answer will be on the next page. In the first case, bromine would need to displace chlorine, since they are both anions. We can infer from the fact that the reaction does not proceed that bromine is less chemically active than chlorine. In the second case, we have to compare the two cations, iron and magnesium. We can infer that iron is less chemically active than magnesium since the reaction does not proceed.